Let's explore auroras borealis with Gisela and Valentina. Today, we're diving into one of nature's most spectacular phenomena, the northern lights, also known as the aurora borealis.
That's right, and we are going to explain how this breathtaking display happens using some fascinating physics concepts.
First up, let's talk about the sun. It continuously releases energy in the form of light, and charged electrons and protons, creating what we call the solar wind.
Exactly. During solar storms or coronal mass ejections, the sun releases an even larger number of these particles. They can travel toward Earth at incredible speeds of up to 800 kilometers per second.
Now, when these charged particles reach Earth, our magnetic field acts as a protective shield, blocking most of them. But near the magnetic poles, that shield is weaker.
Right. This allows some of those particles to enter the atmosphere. They follow the magnetic field's lines, spiraling down toward the poles where they interact with atmospheric gases.
And here's where the magic happens. When those high energy electrons collide with oxygen and nitrogen atoms, they transfer energy and excite those atoms.
But the atoms can't stay in that excited state for long. When they return to their normal states, they release energy in the form of light. Voila! We see the northern lights.
And the color of the auroras? That depends on which gas gets excited and at what altitude the interaction occurs. Isn't that fascinating?
Absolutely, but there's more. The northern lights aren't just static, they are dynamic, appearing as shifting waves, arcs, or spirals.
This movement is influenced by variations in solar wind intensity, how particles interact with Earth's magnetosphere, and changes in magnetic field lines.
Some auroras flash rapidly, while others look like slow-moving curtains depending on the energy of the incoming particles.
Scientists use tools like the KIPI index to predict auroral activity. This scale ranges from 0, which indicates low activity, to 9, which means extreme geomagnetic storms.
The higher the index, the stronger the auroras can be, and they might even be visible at lower latitudes.
So, the best time to witness these amazing displays is during periods of high solar activity, when Earth's magnetic field is disturbed.
It's incredible to think about how the northern lights showcase fundamental physics principles like electromagnetism and atomic excitation in such a beautiful way.
They truly are a mesmerizing natural phenomenon.
So, next time you see the northern lights, remember you are witnessing physics in action. Fun facts. Did you know that while auroras borealis are typically seen in polar regions, there have been rare occasions when they can spot in northern Mexico? These stunning light displays are usually a treat for those living in places like Canada or Norway, but during strong solar storms, the vibrant colors can occasionally dance across the skies of Mexico. Northern lights not only are exclusive to planet Earth. According to NASA, these astronomical events have been captured on Jupiter and Saturn. Beyond the scientific explanation, auroras hold cultural significance in many traditions. For example, in Nordic mythology, they were seen as the reflections of the Valkyries' armor or the fire of a magical fox. These cultural interpretations highlight the deep sense of wonder and mysticism that the auroras have inspired in people for centuries. In conclusion, the Northern Lights are not only a spectacular natural event, but also a beautiful intersection of science and culture, inviting both scientific inquiry and cultural storytelling. As our understanding of the physical processes behind the auroras continues to evolve, their cultural significance will undoubtedly remain as an essential part of human fascination with this incredible phenomenon.